Hello and welcome. My name is Peter Ramm, and together with my colleagues Maximilian Frank and Heinz Lovis, we are the Medical Product Competence and Research team at Customed. Today I would like to give you a concise overview of how we at Customed use artificial intelligence in cardiological diagnostics and what role it can play in everyday clinical practice in the future. The starting point is easy to explain. Our classic rule-based ECG algorithms are stable, transparent, and easy to control from a regulatory perspective. However, they reach their limits when it comes to complex, individually varying patterns. For example, when differentiating between ventricular extrasystoles or atrial fibrillation, overestimations or underestimations can occur. AI-based models offer clear diagnostic added value here. They are able to recognize nonlinear and subtle patterns, such as in silent atrial fibrillation, or to detect and automatically exclude unanalyzed ECG segments in Holter ECG recordings. In addition, they enable more efficient evaluation of large amounts of data, thus contributing to improved sensitivity and specificity. At the same time, it is important to emphasize that AI is no substitute for clinical expertise. The limited explainability of many models, the high demand for high-quality data, and possible distortions due to training data make critical embedding in the clinical context absolutely essential. From our point of view, the future clearly lies in a hybrid approach. Rule-based methods remain essential for standardized and reproducible parameters such as QRS duration, QT interval, or classical rhythm analyses. AI complements these where complex patterns need to be recognized or prognostic statements made. We currently use AI at Customed for the following purpose, among others: to differentiate between normal beats and extrasystoles, both ventricular and supraventricular, to detect and label atrial fibrillation, to continuously evaluate signal quality, to derive respiratory rate via ECG-based respiration. Further development is focused on improved arrhythmia detection, including for AV blocks of varying degrees and idioventricular rhythms. In addition, existing models are being merged to create a more integrated overall diagnostic picture. At the same time, we are optimizing pre-processing to further improve the quality of the signal base. New possibilities are also opening up in the field of stress ECG, for example, in the determination of ventilatory thresholds, functional performance, and VO2 max. In cardiological rehabilitation, we are pursuing AI-supported heart rate adaptive training. In addition, we are working on determining a so-called biological heart age as a potential risk indicator. A common question is AI in cardiology hype or hubris? In my view, neither. Rather, we are observing a phase of clinical consolidation. Although AI systems show impressive results in study environments, their limitations quickly become apparent in everyday use. For example, in their limited transferability to different patient groups or due to the well-known black box problem. Therefore, AI does not change the role of physicians, but rather expands it. Physicians remain the decisive authority that interprets and evaluates AI results and places them in the overall clinical context. AI will increasingly serve as a diagnostic aid, for example in ECG pre-screening, emergency triage, image evaluation, or monitoring the progression of chronic cardiac diseases. My conclusion is clear. AI is not a disruptive revolution, but rather a gradual advancement in cardiac diagnostics. When used correctly, it increases precision, efficiency, and clinical relevance without replacing medical responsibility. At Customed, we see AI as a clinical tool that creates structure, provides support, and improves the quality of decision-making, always in the service of patient-centered and evidence-based medicine. Thank you for your attention. See you next time. Goodbye.